Hi everyone. In last session, we have discussed about some of fundamentals in chemistry, which are related to properties of fundamental particles like electron, proton, and neutron, their mass value, charge value, specific charge value. All these we have discussed in last class, and we have discussed about atomic number and atomic mass number also. I given one example with respect to sodium. Here, all these we have to remember. Atomic mass, atomic numbers we have to remember. See here on board, I given up to 30 atomic numbers and mass numbers. One by one, I'll read. You have to remember all these values, all these mass number values and also atomic number values. So, atomic number 1, it is hydrogen, represented with H. Atomic number 1, here mass number is also 1. Then helium, He. Atomic number 2, mass number is 4. Then lithium, atomic number 3, mass number is 7. Beryllium, symbol is Be, atomic number is 4 and mass number is 9. Boron, B, atomic number 5, mass number is 11. Then carbon, atomic number 6, atomic mass is 12. Nitrogen, atomic number is 7 and atomic mass is 14. And oxygen, O, atomic number is 8 and atomic mass is 16. Then fluorine, F, atomic number is 9 and atomic mass is 19. Neon, Ne, atomic number is 10, atomic mass is 20. Sodium, Na, atomic number is 11, atomic mass is 23. Magnesium, Mg, atomic number is 12, mass number is 24. Aluminium, Al, atomic number is 13, mass number is or atomic mass is 27. Then 14, silicon, Si, atomic number is 14, atomic mass is 28. 15, phosphorus, P, atomic number is 15 and mass number is or atomic mass is 31. And here element name I am reading here 16, sulfur, S, atomic number is 16, atomic mass is 32. Then chlorine, Cl, atomic number is 17 and mass number or atomic mass is 35.5. Argon, 18, atomic number, atomic mass is 40. Then potassium, K, atomic number is 19, atomic mass is 39. Then calcium, Ca, atomic number is 20, atomic mass is 40. Then scandium, Sc, 21 atomic number, 45 atomic mass. Then titanium, Ti, 22 is atomic number and atomic mass is 48. Vanadium, 23 atomic number, 51 is atomic mass. Then chromium, 24 is atomic number, 52 is atomic mass. Then manganese, 25 is atomic number and atomic mass is 52. And iron, Fe, ferrum it is, atomic number is 26 and atomic mass is 56. Cobalt, Co, 27 is atomic number and 59 is atomic mass. Nickel, Ni, 28 is atomic number and 59 is atomic mass. Then copper, Cu, atomic number is 29 and atomic mass is 63.5. And zinc, atomic number 30 and atomic mass is 65. So here I given for 30 elements their atomic numbers and mass numbers I given. You have to remember, you have to note down by passing video. You have to note down all these things and every day you have to by head. Up to 30 you should know atomic numbers and also atomic masses. Okay. Okay, here I am giving one example. 30 zinc 65. Here I written question. Find the number of electrons, protons, then Z is nothing but atomic number, A it is mass number and N number of neutrons. All these we have to find. See here, this is Z. This is a subscript Z. Z is nothing but atomic number. Atomic number. In last session we have discussed atomic number is nothing but what? Number of electrons. Number of electrons, otherwise it is equal to number of protons. number of equal electrons and number of protons in neutral atom. In neutral atom. Then this is 65. This is A value. A is nothing but atomic mass. Otherwise mass number. Otherwise atomic mass. It is nothing but number of neutrons plus number of protons. Otherwise atomic number. Here P is nothing but atomic number only. Here number of protons are nothing but atomic number. So from this we can find now. So first they are asking about electrons. Electrons are equal to atomic number. Atomic number is nothing but 30. Number of electrons are 30. Then second thing what they are asking protons. Number of protons in neutral atom is again equal to atomic number only, that is 30. Then after they are given, they are asking about Z. Z is nothing but atomic number, that is also 30. Then they are asking A. A is nothing but mass number. Mass number is nothing but number of protons plus number of neutrons. Otherwise, this is mass number. So directly I am writing 65. Lastly, they are asking about N, number of neutrons. Number of neutrons for this, we have to use this formula. A equal to N plus P. N equal to what? N equal to A minus P, otherwise A minus Z we can write. P is nothing but Z only. So N value is equal to here 65 minus 30. 65 minus 30, it is equal to 35. In this way, we have to find the different particles which are given in a given element. So here number of electrons, number of protons, then atomic number, mass number, then number of neutrons. Most of the cases they ask the number of neutrons present in given atom. And here next we will discuss about some more terms. They are nothing but isotopes, then isobars, isotopes, isobars and isotones. What are isotopes? What are isobars? Then what are isotones? So one by one we'll discuss. Here, first isotopes. Isotopes definition. They are the atoms of same element. They are atoms of same element with the same number of protons or same number of electrons and different mass numbers. Different mass numbers. See, isotopes are nothing but atoms of same element. Atoms of same element with atoms of same element with same atomic number. Same atomic number and different mass numbers. Different mass numbers. Atoms of same element with the same atomic number Z and different mass numbers A are called isotopes. Isotopes. Here I am giving an example. Simple example and best example is 1H1, then 1H2, then 1H3. This is a simple example. 1H1, this is a hydrogen. These are hydrogen isotopes. See here, this subscript which indicates atomic number. Atomic number is same for all these. And here superscript 1, 2, 3. Mass numbers are different. So atoms of same element with same atomic number and different mass numbers are called isotopes. This is one example. Then here one more example I am giving. This is 92 uranium 235 is one. Other one is 92 uranium 238. These are also isotopes. This first example is 1H1, 1H2, 1H3. Second example I wrote there 92 uranium. U means uranium 235 and 92 uranium 238. One more example also I give here. Chlorine Chlorine also have two isotopes. One is 35 isotope, other one is 37 isotope. One is 35 isotope, then 37 isotope. Here I am writing one more example for isotopes. Here 17 chlorine 35, then 17 chlorine 37. So in all these examples, we can observe same atomic number and different mass numbers. Here same atomic number and different mass numbers. So these are nothing but isotopes. Isotopes are nothing but atoms of same element with the same atomic number and different mass numbers are called isotopes. That are different examples. See here in this we have to again find this number of electrons, number of protons, then mass number and number of neutrons. So based on that we can write some properties. See here this is first example I am taking. 1 H1, then 1 H2, then 1 H3. This is normal hydrogen. This is called as deuterium because of its mass is more, heavy hydrogen. This is tritium. This is also called as radioactive hydrogen. See here I am writing different properties. Properties means Z value, A value, again number of protons, number of neutrons, those things will write here. So first thing here is Z I am writing, Z value. Second A. Third electrons, number of electrons. Fourth number of protons. Then fifth number of neutrons. Those are different things. For hydrogen, what is the Z value? Atomic number? Atomic number is 1. And atomic mass number here is 1. Number of electrons is exactly equal to Z only. It is 1. Number of protons also 1. Number of neutrons here is A minus Z. Number of neutrons N equal to, what is the formula? A minus Z, otherwise A minus P. This is the formula. Z is nothing but number of electrons or number of protons present in neutral atom. So here 1, 1, 1 and here we can write 0. Similarly for this, Z value is 1. Z value is 1. Then A value here 2. Atomic mass is 2. Then number of electrons are 1 and number of protons also 1, here 1 and number of neutrons 2 minus 1. Number of neutrons equal to A minus Z. A value is 2, Z value is 1. 2 minus 1 is 1. See then here for tritium 1H3 isotope, Z value is 1. A value here it is 3. Number of electrons 1. Number of protons also 1. Number of neutrons 3 minus 1. 3 minus 1. 3 minus 1 is 2. So these are the different properties of isotopes. See here we should know one more thing, that is about chemical properties and physical properties. See here chemical properties of any element. Chemical properties of an element depends on number of electrons. If number of electrons are same in two different species, they will have similar properties, similar chemical properties. And physical properties depends on their heaviness, their number of neutrons. See here, based on that, what we can write here, all these isotopes, 1H1, 1H2, 1H3, all these isotopes have same number of electrons, 1, 1, 1. So that all these have same chemical properties. All these have same chemical properties. Why all these have same chemical properties? Due to same number of electrons. Same number of electrons. So this is first thing. All these have same chemical properties. Why all these have same chemical properties means they have same number of electrons. And here number of protons also same and number of neutrons are different. One more thing what we can write here is 1H1. It does not contain neutrons. Does not contain neutrons. See here, number of neutrons are 0. And physical properties are different. Physical properties are different. Physical properties are different. Why physical properties are different for all these? Because they have different masses. They have different number of neutrons, and they have different masses due to different mass, different masses, and different number of neutrons, different number of neutrons. Here I am writing different number of neutrons. They have different same chemical properties and different physical properties. Same chemical properties due to same number of electrons, different physical properties due to different masses and also different number of neutrons. So chemical properties are decided by or chemical properties depends on chemical properties depends on number of electrons present in present in outer shell present in the outer shell of a particular atom. So this you have to remember. Chemical properties always depends on number of electrons present in outer shell or valence shell of that particular atom. So in all these isotopes, they have same number of electrons, so they have similar chemical properties, and they have different physical properties because of their atomic mass is different or number of neutrons also different. So this is about isotopes. And here, because of presence of different isotopes in the nature for given element, we'll get sometimes fractional atomic mass. Here we have two things. One is atomic mass number. Mass number is whole number. Remember here, mass number generally mass number is whole number, but atomic weight, atomic mass, otherwise atomic weight we can say. Atomic weight is fractional value. Atomic mass is fractional value, and after rounding off we can get a whole number. That is mass number. Atomic mass is a fractional value. Due to it is why it is so? It is due to presence of isotopes. Due to presence of isotopes in the nature, because the different isotopes have different mass numbers, different isotopes in nature. This you have to remember. Mass number is generally whole number, but atomic weight or atomic mass is fractional value. Sometimes 35.5, sometimes 63.5, like that I written. So why fractional value those atoms got? Because they have different isotopes in the nature. Based on their isotopic masses, we can get fractional value also sometimes. We can get sometimes fractional value also. Okay. Then here how to get average atomic mass, otherwise average isotopic mass, now we'll discuss. Some more examples also I given just now. Just you try in this way for chlorine, for uranium isotopes. Just try to write in this way, that a tabular form. What is atomic number? What is mass number? How many electrons are present, how many protons are present, all these things just try to write. Now I am giving one formula to get average isotopic mass. Along with that, I'll give one problem also. Average isotopic mass. Average isotopic mass equal to, here, sum of masses of different isotopes present in the nature and number of that isotopes present in the nature. For example, number of isotopes are 5. So here instead of n we have tried 5. So each and every isotope has the different mass. One isotope has 2 mass, other isotope has 2.1, one more is 1.9. Like that, different masses are there. No, that mass we have to write here. Different masses and different numbers by sum of number. This is the formula. If you expand this, we can write m1 n1 plus m2 n2 plus dash 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 up to mi ni, means final how many are there, that many, by n1 plus n2 plus dash 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 plus ni. This is the formula for getting average isotopic mass. So average isotopic mass may be in fractional, because atomic mass or atomic weight, these are fractional values because of different isotope present in the nature. But mass number is rounded value of this atomic mass. It is whole number. It is mass number is nothing but whole number. See here I am giving one example. Here I am giving one example. I am writing a problem here. Abundance means, here I am writing abundance of chlorine 35. This is mass chlorine 35, you know, atomic number 17, and chlorine 37 in the nature. In the nature is 74.8% and 25.2% respectively. Respectively means here chlorine 35 is with 74.8%, chlorine 37 is with 25.2% respectively. Here they are asking about calculate average isotopic mass. Calculate average isotopic mass of chlorine. They are asking about this question. See here, this formula you have to use. Here average isotopic mass. Here only 2 isotopes are there. So average isotopic mass equal to, I am writing m1 n1 plus m2 n2 by n1 plus n2. Only 2, because 2 isotopes are there in the nature. Here m1 I am writing 35, then n1 how much related to this 74.8. That means total chlorine 35, chlorine 37, including both, total number of atoms are 100. Among 100, 74.8 atoms are with respect to 35 mass. Remaining m2 is how much? M2 is 37, and with respect to this n2 value 25.2. That means 25.2 among 100, 25.2 number of atoms are with respect to 37 mass. So these values you have to substitute here. So I am substituting here. M1 is 35 into 74.8 plus M2 is 37 into 25.2 by N1 plus N2. N1 is 74.8 plus 25.2. If it is percentage, always this denominator part n1 plus n2 is equal to always 100. So here we will get, if you multiply this, here we got 2618 here, 2618 plus 37 into 25.2, I got here 932.4. 932.4 I got, by it is 100. So here 2618 plus 932.4 equal to 3550.4. 3550.4. 3550.4 by 100. So how much it will be here? 35.504. This is the atomic weight or atomic mass of chlorine. So how much you got? 35.5. 35.5 means it is fractional value. So that we can write chlorine like this. Chlorine 17, here 35.5 we can write for chlorine. Why we get 35.5 means because of this abundance. This is the experimental finding. Abundance of chlorine 35, chlorine 37 in the nature is given. How much as per experimental findings? 74.8% of chlorine 35 and 25.2% of chlorine 37. So by using this, if you calculate average isotopic mass by using this formula you have to remember. Not only for this, for different other atoms, we have carbon isotopes. 12 carbon, 12, 6 carbon 12 is there, 6 carbon 13 is there, 6 carbon 14 is there. So relative abundance you have to check. So based on relative abundance, we can get average isotopic mass. So average isotopic mass may be fractional because of their abundance in nature. By these questions they may ask. So then isobars, isotopes is completed. Up to here you have to remember. I'll give isobars definition, then we'll conclude this session. What is isobar? Isobar, it is similar to isotopes only, but opposite. Here in isotopes, atomic number is same, mass number is different. But in isobars, mass number is same and mass number is same, then atomic number is different. That means these are the atoms of different elements. Second thing, isobars I am writing. Isobars. Isobars means they are the atoms of different elements. Atoms of different elements and having a same mass number, and different atomic number, are called isobars. See, I am giving one example here. 18 argon 40, then 20 calcium 40. So once you observe these two, so what is the atomic number here? 18. What is the atomic number here is 20. So that these two are having different atomic numbers, means that they are the atoms of different elements, and mass number is same. And atomic number is different. See, one more example I am writing here. 6 carbon 14 is there. Similarly, 7 nitrogen 14. Here also atomic numbers are different. So that these are atoms of different elements with the same mass number. So that here atomic numbers are different means number of electrons are different. So that automatically we can write these have different chemical properties, not same. Different chemical properties. These have different chemical properties. Why? Due to presence of different number of electrons. And here you can observe here for this example, 40 minus 18. 40 minus 18, how much it is here? 40 minus 20. Number of neutrons I am writing here. number of neutrons here is 40 minus 18. For this number of neutrons equal to 40 minus 20. Here it is 20 number of neutrons are present. Here 22 number of neutrons are present. So different number of neutrons are present again here. So nucleons are different. So that we can expect different properties. So mass number is same, but different number of neutrons are present. So based on different number of neutrons, we may expect some different nuclear properties, and based on that, we may expect some different physical properties also. Same different chemical properties and different physical properties, because these are totally atoms of different elements. Totally atoms of different elements. So that these have different chemical properties and different physical properties also. So this is about isotones. In next session, we will discuss about isotones and some more information which is related to these fundamentals in chemistry. Okay, thank you.